Hi everyone. Today we'll be discussing the system design for a newsfeed system. The objectives of this system design will be firstly for the users to quickly see who they are following and who are their followers. Secondly, a low latency news feed for the posts from the users that the user is following or user follows. And the post has to reach all of the users' followers quickly. Coming to the capacity estimates. So there will be images and video content. That is, the media content will be there for the post. And, estimating there'll be around 5,000 prints per user. There'll be 10 million daily active users, and each post will be around 150 bytes is the estimate, plus 100 bytes for the metadata of each post. So if there are 1 billion posts per day, there'll be 1 billion into 250 bytes, that is 0.25 terabytes of data per day that will be generated. At a per year level, it will be around 91 terabytes of data. And this for this system, there will be more reads compared to the writes. Now, moving on to a high level design of how the system will look. Uh, the entry point for the user will be a website or mobile, which will be connected, which will also be talking uh, to a CDN, basically for the image or video content to be stored. And when the request comes from the user, it will be sent to the load balancer, and the load balancer will send it to the available web server. At the web server level, we'll be doing the authentication and rate limiting. Authentication will be based on the auth token that will be sent with the request, and rate limiting is to safeguard the system from spam and abusive users. Basically, there'll be a limit on the number of requests a specific user can send. Thus, it will help to safeguard the system from getting overloaded with requests. Right? From the web servers, the request will be sent to the respective service, either newsfeed service, post service, or the notification service based on the action that is needed. Newsfeed service will basically take care of what are the news feeds that need to be updated, or the news feed that needs to be populated for a particular user, or the news feed that is stored for the user that is generating. And post services basically take care of the post that is sent from the user, and notification services to notify the users. Each of the services will have their respective cache and DB as well to store the newsfeed or post, etc. Moving on to writing a post, the API will look like this: /v1/me/feed, and it will be a post HTTP request with the content and the auth token for authentication. From the web server, the request will go to the post service, and the post service can either do a fan out on write or fan out on read. Fan out on write is basically to write to all the followers uh, of the user. The advantage of fan out on write is that once the post is written to the news feed of the follower, and when the follower is trying to retrieve their specific news feed, it is readily available. There is no computation that is needed. But the disadvantage is that if the user is posting the tweet or post is a celebrity or is a user who has many followers, then it is compute intensive, and it will take a long time for the request to be complete, basically to post or update the news feed of many users. Moving on to fan out on read. Fan out on read is basically to uh, uh, it is basically creating the news feed at the time of read. So when the user is reading, it will generate the news feed by reading the from the post DB. This is the disadvantage is that it is time consuming to generate the news feed, but the advantage is that in case of a celebrity user or an inactive user, the compute resources are not uh, are best utilized. We can do a combination of both. So in case of a celebrity user, uh, the post will not be doing a fan out on write. Basically, it will be stored only in the post DB, and once the user does a retrieve news feed, then the post will be added to the news feed of the user. And in case of an inactive user, also say user posts the data, then the post will not be written to the news feed of the inactive user, so that when the inactive user logs in, then the news feed can be generated for that particular user. So this way, the compute resources are best utilized. Moving on, this is in depth on how the writing a post will look like. So from the post service, the post will be written to the newsfeed cache for all the users. The post service will get the followers for this particular user from the GraphDB. For example, FlockDB could be used in Twitter. So assuming we are using FlockDB, it will get the followers for the user and updates its respective news feed, and it can also see whether the user is inactive or not, or it is a celebrity user, and take the appropriate action accordingly. And the post will also be stored in its post cache or post DB. Right. Moving on to reading a news feed, the API is /v1/me/feed will be like this, and the it will be a get HTTP request. Our request will go from the website or mobile to the load balancer to the web server, whichever is available, and from the web server it will go to the news feed service. Now, the news feed service will fetch the news feed from the news feed cache, and from the GraphDB it will also fetch the users that the user is following, and if there are celebrity users, it will get the data from the post cache or post DB for the celebrity user. And if the user requesting is an inactive user, then all the posts will be retrieved from the post cache or post DB. And along with that, it will also retrieve the other metadata for the users of the post DB, like the profile photo and the location for the media content, either the image or a video. And in the newsfeed, will the newsfeed cache, when posting the to the newsfeed cache, it will the content will have only the IDs, like the post ID and the user ID. It will be a map of post ID, user ID. This The advantage is that there's not a lot of memory that will be utilized to store that, and while generating the news feed, all the data with respect to the post ID can be retrieved, and the user ID also can be retrieved and then populated for the respective user. Mm. The image and video will be stored in the CDN, and it will be retrieved from the CDN while populating the data for the user. How do we decouple the post service from, say, the newsfeed cache? So once the post service, once a post is made and is handled by the post service, it has to be updated to the newsfeed cache. So the post service can update a messaging queue, and then we can have a streamlined processing service like Flink, a streamline processing service, a stream processing, a stream processing service like Flink, which will be reading the message queue, and based on the message queue data, it will update the respective newsfeed caches and the newsfeed DB. Similarly, for a follower following service, um, when the follower following service, when a particular user is clicks on either follow or is a new follower is added to a user, then the CDC or change data capture will be updated to the message queue by the follower following service. The message queue could be Kafka, and then a stream processing service like Flink can read this message queue and update the respective FlogDB entry with two entries. One is, say, user A is following user B, and the user B has a new follower, user A. So there'll be two entries that will be made in GraphDB so that it is quick to retrieve on who are the followers and who are following for a particular user. So this covers most of the requirements for a newsfeed system. If there is anything else that needs to be covered, please do let me know. Thank you.